There's different types of encryption flaws. They could be based on weak encryption, strong encryption being implemented improperly, or people using things like, encoding instead of true encryption. And then, of course, there's always configuration or human errors, where you got the right stuff, you got the right software and hardware, but the problem is in the configuration and the implementation. This is still, even today, the most common vulnerability in practice. Right? So let's look at the anatomy of a remote exploit. I kind of introduced you yesterday to the concept of shellcode. And what we said is shellcode is unique in that it can be ran directly in memory. There does not need to be any type of compiler or interpreter in memory or anything like that. If you can get the shellcode onto the stack or in memory, it's going to be executed by the processor. And that makes it very, very useful for, using as payloads to be part of your final exploits. So shellcode is very simple instructions that allow a computer to be compromised, DOSed, or whatever you want. It's also very architecture and OS dependent. So for example, a piece of shellcode that works on Windows 10 Service Pack 1 won't necessarily work against Windows 8 Service Pack 1. So, it's very dependent on the OS and the operating system or the version, and sometimes even the service pack level. Now, the delivery script, that is what we use to put the shellcode into a vulnerable input area. This could be via a protocol field, like a HTTP request or response field. It could also be a user input area, somewhere that a user is allowed to log in a search query string or anything along those lines. These could all be input areas where an exploit could be launched or a piece of shellcode could be forced into memory. Now, there is a technique known as vulnerability mapping, where we map known exploits to vulnerabilities. Vulnerability mapping is essentially what you saw me do when I scanned, found the service, found the version, and I went out and looked for vulnerabilities related to that version and eventually found an exploit. That's essentially what vulnerability mapping is. And if you put it in the scope, you really need to do that for every service that you discover on every device that's out there. And that sets you up for the next part, which is actually going and exploiting the vulnerabilities that you discover. Now, with that, to help you, there are some resources that we have listed here that you can go and find a lot of vulnerabilities and exploits published. And if you can't find any here, you can also look at some of the smaller, more specialized sites like Rapid7 and WP VulnDB. And also you can add to that list ExploitDB is another popular place that we all use to share research and use other people's research. Now, the buffer overflow is by far one of the most common types of remote local vulnerabilities. There's many subtypes of overflows. There's stack, there's heap, there's integer, there's kernel, format string, and many different others. It essentially involves stuffing too much data into a container. When you run a program in memory, that program has its own virtual stack. It's only a certain amount of memory allocated for the program as a whole, and there's a certain amount of memory allocated for different parts of that program. So a buffer overflow occurs when you put something in one of those containers. Let's say is allocated for a certain amount, 15 bytes of space, and you put more than 15 bytes in there. If that 15 bytes is too much and it overflows that container, it ends up spilling into the container next to that container, which is where the overflow part happens. So now you're overriding something in a container that was there before with your something, specifically your shellcode, and with the hope that when that piece of memory gets executed, instead of what was there initially getting executed, your actual shellcode will get executed. And that isn't a successful buffer overflow. There are some countermeasures to buffer overflows: better coding, disable unused services, and also apply vendor patches, filter traffic at the firewall, run software and users and least privilege mode. Basically, stuff that we've been saying for the last 20 years. These are still the top and the best countermeasures for, these things being a problem. Now, the most common type of overflow is a stack overflow. It's behind a lot of high-profile exploits that have happened in the last 20 years. If you want to historically go back, you can go and read the paper Smashing the Stack for Fun and Profit, written by LF1 back when basically we all read Frack magazine, which is an online only text only magazine for hackers, right? And it's all archived, so you can find it on the internet. Now, normal stack utilization, right? So assuming that some of you have never, ever programmed anything, let's say you never even done hello world, right? So let me make this real basic. This is a piece of C code. And what's happening here is, if you can imagine, a program is running, and somewhere in that program is allowing you to enter, let's say, a username. And in the code, it's restricting you to 12 characters or 12 bytes of space for a username. So what happens is it prompts you for a username, and you should be able to enter one, but it should not exceed 12 bytes, because it's going to take whatever you enter. It's going to use this function. This is called the function string copy, and it's going to copy whatever you enter. It's going to use this function to copy that into a buffer. And that buffer is going to be 12 bytes, because that's what's called here and allocated, right? Now, as long as when it asks you for a username, you enter one or enter a string that does not exceed 12 characters, you're fine, because you have a buffer here that can hold 12, and you've only entered, in this case, 6. So you're good. However, if you enter into that buffer more than 12 characters, in this case, we've entered 20. Now what happens is, once you fill this buffer up, data keeps writing beyond that buffer to the next one, which is this, and then the next one, which is this. So now you're overriding other places in memory that were occupied by other things, because of the nature of how memory just works, the way things are moving on and off the stack. So that's a graphical representation of an overflow. I'm going to kind of show you a little basic demo, and then I'll show you an advanced demo of writing an exploit. That demo takes about an hour, but it's a walkthrough of the entire process of finding a vulnerability and then writing an exploit for it. Just to get you started on your labs, we're going to do a much simpler breakdown of that. Now, countermeasures for buffer overflows: balance checking, use safe libraries, static code analysis, executable space protection, and there's even things like canary values. Microsoft introduced some years ago something called ASLR, or address space layout randomization, which means that even if you get an exploit to work, it will only work for that one time, because after that, it won't work anymore. There's stack smashing protection, and there's even some compiler enforced protection. And what that means is it tries to keep you from writing the code in the first place. So it won't even compile it if you've written into the code vulnerabilities